overhead. You see there for the first time an electroscope. We discussed it last time. It is a piece of aluminum foil, very thin, with a metal rod next to it. And when I put charge on the rod, it will also go onto the aluminum foil, and they will repel each other, and so the aluminum tinsel will go to the right. And the more charge there is on it, the farther it goes to the right. So let me first put these two together, make sure they are completely discharged. And now I'm going to bring these two into an electric field which is produced by this rubber rod. I have to rub with the cat fur, and I believe it was negative. But if you'd never have to remember whether it's negative or positive, of course. That is not so important. What is in a name, after all? But it happens to be negative. Okay, so now we go here. I bring it here. I hope that no sparks will fly over, because that ruins the demonstration. And now, notice what I do. While the rod is here, I separate them. So as I was holding it there, things were going on in there that you and I couldn't see. But the electrons, the rubber rod is negative, electrons were shifting in this direction, and this is now positive and that is now negative. If I take this one and I touch it with the electroscope, you clearly see that there is charge on this. How can I show you now that there is charge of different polarity on the other one? Well, the way I will do that is I will approach this electroscope by bringing this sphere very close to it. And if this charge is different than the charge that is on it, the electroscope the reading will become smaller. And why is that? Why will the reading become smaller? Well, here is the situation of the electroscope now. And here is that ball that you see on top. This is upside down there. If this is all negative, that's why it is apart. If now I approach this here with an object which is positively charged, and I claim that this one now is positively charged because this one was negatively charged, then electrons are afraid of the positive charge, so more will go. Excuse me, electrons love the positive charge, so the electrons want to come to the positive charge, so these electrons drift down again. And so if they come down, fewer will be here, and so you will see this. If, however, I put here a negative rod, then the electrons which are here want to go further away, they will stream up, and therefore the reading will become larger. So you can always, through induction, test what the polarity is of your charge. Let's hope that this one is still holding its charge while I was talking. So I claim now that if this polarity is different, and if it's still there, when I approach the electroscope, come very close, that the reading should become a little smaller without even touching it. Let's see whether that works. You see, it goes down. You see, it goes down. It goes down. So through induction, I have demonstrated that this has indeed a different polarity from this one. If I approach it with this one, it would go further out, unless it already is at a maximum. Let's try that. You see, it goes further out. So not only have I demonstrated that I created a dipole, but you've also seen that